Hello people from the future, welcome to Normalized Nerd. So in this video, I'm going to be talking about different evaluation metrics and how you can implement them using Scikit-Learn and StatsModel library, okay? So the main topics that I'm going to be discussing in this video are root mean squared error, R squared, mean squared logarithmic error, mean absolute error, and some variations of this matrix, okay? Now, if you are new to my channel, please subscribe to my channel and hit the bell icon. I make videos about machine learning and data science regularly. So let's get started. So you can see the first metric that I have here is R squared. Well, I have actually made a detailed video about R squared and adjusted R squared where I have talked about the intuition and the mathematics behind this matrix. So I will highly recommend you to check that video first and then continue with this video. Well, I'm gonna explain the terms in the formula in this video also, but obviously I'm not gonna go deeper into the concept. Alright, so you can see the formula goes something like this: R squared equals 1 minus variance of model divided by variance of average. And following the formula of variance, we find this formula. Alright, now what the terms mean: whenever you see yi, you should know that it is telling you the ground truth value. Okay, so this is the ground truth value of the ith sample, and the y hat here is nothing but the prediction by our model for that ith sample. Alright, in the denominator we have yi minus y bar. Well, y bar is the average value of the outputs from our dataset. Alright, and this gives us the formula for r squared. Now when we check out the formula of adjusted r square, as I have discussed in my previous video, in this formula we have made some adjustments to tackle a huge problem, which is even if we increase the number of independent features, the adjusted r square value doesn't increase if we don't see a significant increase in our r squared value. Alright, so this formula was actually invented to penalize the adjusted r square score whenever we are adding new variables to our model. Alright, so here the n denotes the number of data points and m denotes the number of independent features. Okay, by the way, the n here, that is I equal 1 to n, in this sigma is actually same as this n. Alright, so let's get into the code. So what I am doing here is I'm first importing the pandas library because I am gonna use the data frame from that library, and then I am importing the stats model library. Now why I am doing this? Well, usually I make my machine learning models using scikit-learn, but unfortunately till now scikit-learn doesn't have anything sophisticated to find the adjusted r square values. Okay, but statsmodel library has a very nice way of finding important properties of our dataset. So that's why I have used Statsmodel API. Alright, so after that obviously we need to import numpy because hey, we are doing machine learning, numpy is everything. And after that I'm creating actually a fake dataset. Well, I have actually discussed about this dataset in my previous videos. Again, I'm discussing it. So I have taken the example of number of videos that I make in 1 month and the number of free time that I have on that month, and this just denotes the number of month. Okay, so 12th month means December obviously. So for those of you who don't know how to make a data frame in pandas, so what I'm doing here at first is I am creating a dictionary. You can easily see that this is the syntax for dictionary, and these are my keys and these are my values, and you can see that each value is actually a list. And it is actually very simple to create a data frame if we have a dictionary at first. Okay, so this is my data dictionary, and while creating the data frame I am calling data frame, then in the parameter I am passing the dictionary, and I am making the columns as a list of these keys. Okay, so month, free time, and num videos. So at this point we should have our data frame ready to work with. So after that I am taking my matrix of features. Well, we have only one feature here, so I have taken only one column, free time, and then we are extracting the target variable, and in this case it is just the column corresponding to num videos. So our feature has been extracted and our target variable has also been extracted. So now we are adding a constant term here. Well, this will actually act as a bias term, alright? And to add that in Statsmodel, you can just use this syntax dot add constant. So at this point we are ready to fit our model to our dataset, alright? So the machine learning model I'm gonna use here is OLS. Well, this just stands for ordinary least square, and you can definitely read more about it in the Statsmodel documentations. So the syntax to fit the model to our dataset is very simple, and all you need to do is just say sm. Well, sm because I have imported the Statsmodel API by the string sm. Okay, so sm dot ols yx, and remember the order. First it will take the target variable, and after that it will take the matrix of features, and after that you need to put the dot fit method, and at this point you have actually fit the model to our dataset. And after that, obviously we need to do predictions. Now comes the interesting part where we are gonna actually see the r squared and adjusted r squared value, and to do this we can see a lots of different properties of our dataset and results from our model by this single line, which is model.summary. Okay, so if I just scroll down, you can see they have provided you a huge summary of your dataset and model. Now for this video you just need to focus on these two lines. Okay, so you can see the r squared value is 0.818. Well, what does that mean? Well, it means that our model have successfully explained 81.8% variance in our dataset. And if you don't understand what I have just said, the term explained variance, please check out my previous video. And after that we have the adjusted r squared value, which is 0.792, and you can see the difference between them are not very much. So it tells you that we don't have any redundant features or random features, and the values are really close to 1, so we can definitely use this model. And if you happen to know some statistics, then you have probably noticed all these terms like skewness and kurtosis, and here log likelihood and f statistic. Well, I'm not gonna go into all of them in this video, but I just want to mention that how beautiful the function dot summary is. So let's move on to the next set of metrics. And by the way, I have also printed the results also, so just have a quick look on the original data and the predicted values, and you will find that they are very similar. And that is the case, we just showed that r squared and adjusted r squared values are really close to 1, so obviously this is a good model. But unfortunately it is a fake data, so it really doesn't make any sense. So here we have three metrics. Actually I will show you some combinations of them, so ultimately they will be 6, I guess. Okay, so the first thing that I have here is RMSE. Well, it is very simple. It is the abbreviation for root mean squared error. What is the error? Well, in machine learning, whenever you see the term error, you instantly know that this is the difference between ground truth and predicted value by your model. Okay, so then we have the square, so I'm squaring this. Then we have the mean, and at last we have a root, so a square root. A rule that will help you in reading this kind of matrix is that whenever you are writing the formula from this abbreviation, always go from right to left. Okay, so first of all find the error, then square it, then mean it, then find the root. All right, now the next matrix we have here is RMSLE. It looks a little bit intimidating, but don't get afraid, it's really not that hard. So I'm gonna go from right to left. Well, what is the error? We know that error is always the difference between actual value and the prediction value. But you can see there is a logarithm involved, and I hope you know that whenever we have 0 inside of log, it is not defined. So we have to get rid of it somehow. So how to do it? Just add 1. After that, we are calculating the difference. Then there is a s, that means squared. So we are squaring them. Then m for mean. So we are finding the mean. And at last, we have the root term. So a square root. And at last, we have the MAE, which stands for mean absolute error. So first of all, find the error, take the absolute value, and then find the mean. Okay. So now comes the coding part. So to implement all of these, I'm gonna use our favorite library, that is Scikit-Learn, and I'm importing these 3 classes: mean square error, mean squared log error, mean absolute error, from the matrix module of Scikit-Learn. Okay. And if you have remembered, the predictions is actually this array produced by our model, and the y is our ground truth. So to find the mean squared error, I'm just passing these two in the argument of the function. Alright. Now you can see that here I have written the root mean square error. So how to find the root mean square error? Well, it's as simple as writing a np.sqrt before this function. Alright, so we have covered the first two things. Now comes the RMSLE, but before that, we don't have a function for RMSLE, but we do have a function for MSLE. So first find the MSLE, then just add a np.square root before that to get the RMSLE. Now at last we have MAE, mean absolute error. Oh, we have only 5. I thought we had 6. Okay, so that doesn't make any difference. Okay, so that was all for the implementation part, but now I want to give you some intuition about which metric you should be using for which case. If you see a huge difference between your predicted value and the actual value, then you might want to use this logarithmic thing, because obviously whenever there is a logarithmic involved, it will decrease your errors exponentially. All right, so if your differences are really big, use that one. If your differences are not that big but not that small also, then I will suggest you to use RMSE, root mean squared error. And if your differences are really small, then I will recommend you to use MAE. But this is just my recommendation. There is actually no hardcode rule about using some metrics for one case and some metrics for the other. So it is really up to you. So that was all for the video, guys. It was a really quick video, and I hope that you have learned something from this video. And if you have, please subscribe to my channel and hit the bell icon and share this video obviously. Thanks for watching.